Hello, my name is Roger Jones, and it is a pleasure being with you virtually today. I'm going to initiate a playful discussion on the differences between the way engineers design computers and the way that natural selection designs biological computers. Since much of our engineered computation mimics biology, from neural networks to genetic programming, it's important to understand the differences between engineering design and biological design in order to be able to create capable engineered solutions. The roots of this conversation go way back to ancient Greece and India, and yet the conversation is as modern as conversations with Siri on our cell phones. I want to talk about this topic in very general, multidisciplinary terms to a broad audience. There's not a single equation or computer simulation in this presentation, although there are some results from a modern biology lab. To set the tone, I would like to start with a story from ancient Greece that I believe many or all of you know. This is a simple story. I'm sure you know it. It involves an alpine village, some sheep, the villagers, and a wolf. Oh, and also a young boy whose task was to guard the sheep while the villagers slept. First, I will tell the story in the original manner from the point of view of the villagers, but I claim this is not the only way to tell the story. I will also tell the story in a different way with a different moral. There's a village in the mountains composed of villagers, of course. They spend their days cultivating mountain crops, potatoes perhaps. They also have a herd of sheep to provide wool for income. Since the villagers work in the fields during the day, they have tasked a young boy to watch over the sheep while they sleep. One night, the boy runs into the village shouting, "Wolf!" The villagers respond by going to the pasture where the sheep reside and searching the area for signs of a wolf. They find none. The same thing happens the following night. When the boy ran into the village shouting "wolf" on the third night, the villagers concluded that no wolf was present and the boy was a habitual liar. They refused to stir from their beds, and an actual wolf emerged from the trees and ate the sheep. If you ask someone who heard the villagers' version of the story what the moral is, they would say that one should not lie if one wants to be believed. Without the income from the sheep, the villagers all died in the winter. Well, that's a sad story for the villagers, but a happy story for the wolves. Let's tell the story from the wolf's point of view. The first night, the wolf shows himself to the boy and then retreats deep into the trees. The boy goes into the village, cries "wolf." The villagers check the area around the sheep. The wolf repeats his actions the second night, and the scene replays. The third night, the villagers do not return to the pasture. The wolf calls in the pack, and they feast on sheep. The wolf pack survived the winter then because of their innovative actions. And of course, the villagers died in the winter. But what if there had been a wise man in the village who asked the question, what if the boy is not lying? If a wolf eats our sheep, we will not have enough income to survive the winter. The wise man convinces the villagers to continue to inspect the pasture every time the wolf shows himself or the boy cries "wolf." This goes on forever. The wolf pack dies from starvation because it can't get any sheep. But the villagers also died because they spent so much time watching for the wolf, their fields went barren and they starved over the winter. The moral I would take from the story is that the villagers need to think outside the box in order to survive. I would tell the story with a better outcome for the villagers. The villagers kept a small fire burning on the path near the outhouse, which was near the barn, so that people could warm themselves in the night before they trekked back to the house. In In my story, there is a second wise man in the village who noticed that wolves never came around to bother the livestock in the village when a fire was burning near the barn. He suspected that the fire was keeping the wolves away. So he took a couple young men up to the pasture with dried cow dung from the village milk cows. He instructed the boys to make a fire each night and keep the sheep in the vicinity of the fire. The wolf stayed away from the fire. Even though the boy could see the wolf in the shadows, he did not panic. The villagers tended to their fields in peace during the day. The wolves never ate sheep and died from starvation in the winter. The villagers survived the winter just fine. The villagers survived because a process, the fire, that was used to keep people warm when they used the outhouse in the night could also be used to keep wolves away from the sheep. The second wise man was clever and innovative. But what does the boy and the wolf and the villagers have to do with computation? Be patient. We're getting there. First, we need to see what Aristotle has to say about the wolf story. Aristotle developed the concept of the excluded middle. This concept basically states that all statements are either true or they're false. And all statements are true or false. There can be no other option. The villagers took Aristotle's point of view. The wolf was either there or was not there. The boy was either lying or not lying. This manner of computation led to the failure of the villagers to survive. Let's talk about Buddhism. Buddhists hold the position that one should take a middle path to never commit to one extreme action or its opposite. The wolf took a more Buddhist position. It was either in the pasture or was not in the pasture, deep in the woods. The wolf didn't care if the boy was a liar or not a liar. The wolf just waited until the situation turned his direction, and then he took advantage of it. Well, this worked well until the first wise man of the village brought all the villagers to guard the sheep, and the situation never turned in a manner that favored the wolf. This led to the failure of both the wolf and the villagers to survive. Let's talk about biology. The second wise man implemented a solution that saved the villagers. This is unlike the other two implementations, the excluded middle or the middle path, in which the villagers did not survive. Basically, the wise man took a process, fire, that was common in the village, in this case to warm hands, and used it for a completely different application, protection of sheep from wolves. This kind of strange creativity is quite common in biology, and I'll point you to the origins of mitochondria as a great example. Engineered computers follow the path of the excluded middle or the middle path, both. They follow the excluded middle when you take an input tape with ones and zeros, either ones or zeros in each spot, input it into the computer, a bunch of ones and zeros flip up and down, and output another tape full of ones and zeros. Okay, that's what happens in a computer that's operating in the excluded middle. An operating system or a computer operating in the middle path takes a tape with ones and zeros up and down, put it into the computer, and what happens is the little time wheel goes around and around and around, or maybe it's an hourglass, but it just goes on forever. That is the middle path. Biological computers, like engineered computers, have on and off switches. For instance, phosphorylation sites on proteins can be phosphorylated or they can be dephosphorylated, on or off. But biological computers have one other type of switch that's very interesting. They have inactive switches. These are switches that are held in reserve and are only brought out in reserve when they are needed for survival of the organism or species. Here's a very recent paper that describes what might be going on in terms of natural selection and basic physics principles. There seems to be reasonable experimental verification of the picture we're talking about. I invite you to look at this paper and others to get a sense of where we are on this topic. Here's a nice quote from Stuart Kauffman on the topic. We have a shadow future hovering on the edges of the present state of things, a map of all the ways in which the present can reinvent itself. What Stu is saying is that we cannot predict how populations will evolve under natural selection. The reason is that natural selection is constantly expanding the space in which it explores. Natural selection and the space that's explored by natural selection interact with each other, making predictions a priori impossible. What most of us do when we solve problems using genetic algorithms, say, is very, very different from what biology seems to be doing. For solving a problem with a genetic algorithm, we have a space, perhaps it's a very large space, and we would like to find an optimum solution in that very large space. Well, this is not at all what we've been describing here. Biology solves the problem of starting with a very large space, finding a quick solution or optimal solution, but that solution changes the space that the search is going on in. So what biology is doing is invention, where what I'm doing, or perhaps some of you are doing, when we use genetic techniques to solve problems, is more a brute force kind of search of a large space. It's a much different problem. Let's take this crazy mental journey home. As our wolf story illustrates, invention seems to be very important for survival. The tools of both Western and Eastern thought seem to be inadequate to describe how an organism is to survive. This is illustrated by the figure on the left, where the saber-toothed tiger eats both Europeans and Asians indiscriminately. Invention can temporarily benefit one population over another until that population innovates as well. An example in the wolf story is that the wolf had an initial advantage because it had an innovative new strategy for tricking the boy shepherd. Well, that only lasted until the second wise man came along and came up with the fire strategy to counteract the wolf. So then the villagers came out ahead. Says life is only temporary. What I'm trying to say here is that if we use genetic algorithms and genetic programming solely for global optimization, we may not be using these techniques to their best advantage. Thank you for listening. I'll take some questions now. Contact me. I'll leave my email on the screen for a few seconds. Contact the session chairman if you need my coordinates. Bye-bye. Be safe.